Hello, this is Mottzy back with another Mottzy Minutes. Today I will be looking at using a sorting algorithm in Smile Game Builder. Now, this is a little bit different than a sorting algorithm in many programming languages because the system for eventing, as they call it in Smile Game Builder, is a little bit less advanced than what you can do in a programming language. It also means I'm going to need to spend a little bit of extra time showing you how this works and how a sorting algorithm can be implemented even with Smile Game Builder's eventing system. First, I'll show you an example of how sorting works. I'm going to pull up the Smile Game Builder debug console so I can actually show you how the variables get sorted. I'm using the MarkeBaseSGB project that I created, and so any variables I'm working with, I need to use a higher number for my demonstration. This assumes someone may want to use this project for their own work, and I don't want to have my variables conflict. For this demonstration, I'm going to be using numbers 900 to 914 to set up a set of random numbers I want to sort. Then I'll be using numbers 920 through 934 to show you the sorted version. Let's get this set up. I have a simple event here, and it will prepare a set of 15 random numbers for me to sort. As you can see, the numbers are already set up from number 900 here down to 914, and they are in some random order. Now it's going to ask me if I want to sort these ascending or descending. This algorithm allows for both. For this demonstration, I will use ascending. And finally, it will start sorting. In order to demonstrate this as it goes, I put a 1 second timer in between each loop so we can see it actually sorting live. And as you can see, it is sorting this all in ascending order. It is all complete, and now I have a perfectly sorted list of variable numbers. Before we look at how the eventing works, I'd like to take a look at a diagram I created to demonstrate how the sorting actually works. I'm using a tool called draw.io or app.diagrams.net. I believe they changed their name recently. This example is set up as a simulation of what sorting might look like. Each of these boxes on the left represent a variable number. So this is variable number 1, this is 10, 11, 12, 13, 14, and so on with 2 and 20 through 24. The boxes to the right represent the value that is stored in the variable. This sorting algorithm makes extensive use of this notion of advanced variable getting the value of the variable box as a value to use. What I mean by that is this is called an iterator. When I loop through the values to sort, I need to use a number to find out what I'm sorting. This says 10. What this is actually going to do is it's going to use the value that is stored in this variable to start its sorting. For me to walk through this, I'm actually going to modify the diagram and show you step by step how the iterations will work. So whenever I want to sort, I need two sets of variables. I need the set of variables I want to sort, and I need some sort of output that they're going to be stored. This is required because I can't sort values if I'm changing them as I'm looping through. These are somewhat advanced concepts, and it does use things like loops and so on, which means if you don't know how those things work, you may either want to follow closely along or look at some remedial information on Smile Game Builder on how to use loops and advanced variables. With this sorting, I first start with number 10, as I said. This is what I'm going to loop through. So the first thing it's going to do is it's going to get the value from number 10, and it's going to store it into another variable, which we call current. This can be any variable number. It could be 20, 5, 30, or whatever. It's not really important, just to know that I have a different variable I'm storing the current value. Now, once it has this value, it needs to do yet another loop. I basically need to pick up this number, and then I need to take this number and compare it with everything that's currently stored on this second set of output variables so that I know where it needs to fit. This is effectively using what's called an insertion sort, although unlike most programming languages, it does some more low-level stuff just to make it work properly. So I have this value, I need to do a subloop, and that subloop has a sub-iterator. Like before, we use the value here, the 20, in order to do a comparison. So 20 is going to pull the value at variable 20, and it's going to compare 5 to 0. In the eventing script, I do a little bit more with variables. For this demonstration, it suffices to say that somehow I need to take this number and compare it to the first number and find out which one is greater or lesser. Because I use ascending in my example, I'll use the ascending version of the algorithm to describe how this works. The first thing we do is we want to find out if 5 is less than 0. Because we're using zeros here as sort of a empty indicator, 0 actually means we can just place 5 directly into this box. We don't have to really do an evaluation. We just say it's 0, so therefore whatever this number is can just be plopped in. And now we can move to the next step in our iterations. So we make this number to 11. We go down to 11 here. We pull out this number, and it becomes current. Now we start all over again with sub-iterator at 20. And we look at number 20 and we find out whether the current value is less than the value that's stored. As we can see, it's not less than the value that's stored. So we go to the next item. And that means the sub-iterator needs to move up by 1. And now we go to 21. And as before, since this is 0, we just place the number directly in its spot. Then we have to reset everything over again. And finally, we raise this number up by 1. And we go down to 12 and we put 1 into the current value. So we are now working on this number and putting it into current. And we start over yet again to do the comparison. Now we can see that 1 is definitely less than 5. So what we end up doing is we put 1 into this box and we put 5 into this box. Now this is where the actual insertion part of the algorithm starts to come into play. Whenever we have to replace a value, now we have to continue the loop and use the value that we took out or replaced. So now 5 becomes current. We set this to 21, and we move down to check out what 21 equals. In this case, again, 5 is less than 30, so we replace the number, and we put 30 into current, and proceed with the algorithm. And finally, we hit a 0, so we can just put this number straight in here and move on. Now I'm going to proceed all the way down to 50. And finally, we have finished our iterations and we have ended up with a sorted version of the list. Now let's go look at how the actual event script works. Far more complicated than this diagram. However, I will refer to this diagram to at least give an idea of how sorting might work with the script itself. Here we are back with our common event in the MarkeBaseSGB. You can see I have a sort script, which we'll look at now. This is all done in a single script, and I am using the script view, the text view, in order to be able to compact this so that it's more readable for the tutorial. You'll also see that I've added these note boxes, which is part of the insertion here with the miscellaneous items, where you can put notes into your script. This helps better understand what the script might be doing at any given point. The first thing I want to do is take a look at the variables that we're going to use. As we can see, doing sorting takes a few number of variables. At the top here, I have what I would call the parameters that are necessary in order to make this work. The first is the sort start. This is the number in which I want to start looking at values in order to sort them. In my diagram, that would be this value right here. Sort start would be the 10, because I want to start at variable 10 to start looking at values to sort. Then we have sort size. Sort size is telling me how big of a set of variables I want to look at. This is very similar to having an array in most programming languages. So if sort start is 10, sort size would be 5. 1, 2, 3, 4, 5. It's saying that I want 5 total variables to sort. Sort end is used internally by the script, and that is to calculate this value at the end, which would be number 14. Sort output index is telling me where I want the sorted values to go, which is all the way over here in 20. This is the value that needs to be set before the script can be called, and it does end up using sort size in order to determine how many values it needs to reserve. Iterator, iterator end, and iterator check are all part of doing the loop necessary to make a sort work. There are also 3 variables that can use basically anytime you want to do a loop that involves using a number that needs to iterate up or down. Subiterator, subiterator end, and subiterator check, all 3 are part of the second loop that we need to make this script work. So we use iterator, iterator end, and iterator check on this left side, and the subiterator versions on the right side. Sort current value represents the current value that we're trying to sort. That is the current that you see on the diagram on the right. Sort current output value represents the number that we're testing in the sort output, which is here on the far right. And sort compare is what we use in the script in order to compare the values and determine which one is greater or less than. Now we know what the variables are, let's take a look at the script. The first thing that we need to do to make this work is we have to initialize the output that we're sorting against. That means that whatever values I have reserved as my sort output, I need to make sure every single one of these are 0 to start with. So this first loop is just setting up an iterator and an iterator end. As you can see, we first start by setting the sort output index to the iterator value. That's saying it's 20. Then we need to do 2 things in order to get the iterator end set up properly. First, we set the value of iterator end to the sort output index. Then we add the sort size to iterator end to get the output value. You may also notice at the very top, I have to subtract 1 from sort size. Because we know that the start value is a value we want to use, we only want to add the number to that value in order to get the end, which would be 1 less than whatever the sort size is. So with my example, the output index would be 20, the sort size would be 5, and it would become 4 when the script starts. And then when I add 4 to 20, I get 24. Now we have to start a loop. Loops can be added over in the miscellaneous section. You can see there loop. And there's also this escape loop, which is really critical in order to make a loop stop running. If you don't use escape loop, your loop will run forever. The first thing we do in this loop is we assign 0 to the value of the iterator's location. And if that sounds confusing, I'll go back to describing how number displayed in variable box works. If I'm using advanced variable op and I want to set the value of a variable to the number displayed in a variable box, then what I'm actually saying is if iterator is 20, then I want to set whatever this how is, in this case it's 0, I want to set the value of variable 20 to 0. So even though I'm using iterator as my reference, iterator holds the value 20, and therefore it's actually going to set the value of variable 20 to 0. As I noted in the beginning, I make extensive use of that in these loops, and it's very important to understand the difference. If I use variable box, it will set the value of the iterator to 0. But if I use number displayed in variable box, it'll take whatever is inside of this iterator and look at that variable to set its value. The next part of this loop I use 3 different times in this script. And all it is a check to see whether the loop needs to finish. So to do that, I have to do a check. I have an iterator check, and I set the value of iterator check to whatever the iterator end is. For this loop, the iterator end is 24. So that would be iterator check equals 24. Then I need to subtract the value of the current iterator from iterator check and store it back into iterator check. That's exactly how this works. Basically, I'm taking variable box of iterator, subtracting iterator check, and I should end up with a positive number as long as iterator is less than the value of iterator end. So if the iterator is 20 and iterator end is 24, then 24 minus 20 would be the number 4. But when the iterator is 24 and the iterator end is 24, I should end up with the value of 0. So here we go with check variable box. You can see the contents need to be less than or equal to 0. If they are, we escape the loop. It says that this loop is done. Otherwise, with check conditions do not apply, I just add 1 to the value that's stored in iterator. It will continue through the loop from 20, 21, 22, 23, 24, setting all those values to 0. And then it will escape the loop and move on to the main section. This next section is the main section of the sorting algorithm. In the beginning, we need to set up the iterator all over again, and in this case, we're resetting it to do a type of loop like I set up here in my example on the right. So first, we have to set the iterator to be the sort start, which would be 10 in this case. Then we need to set up iterator end in a similar way that we did up above. That means we're going to take 10, we're going to add 4 to it, and we'll end up with 14 for our iterator end. Finally, for the sub-iterator end, we know it will always be the same number, so we set it up here early so we don't have to keep resetting it within the loop. This first loop here is what happens on the left-hand side, just as I showed in my example. So the very first thing we do is we take the value here at 10 and we put it into the sort current value. And then in this next spot, we reset the sub-iterator to be the first number that it needs to be from the beginning. In this case, it's 20. Then we start our sub loop. So as you can see, we have one loop started and we're starting on a second one. And that's because, as per our example, current in this case would be 5. And we're ready to go and check whether 5 fits in anywhere within this sorted set. So the very first thing that we're going to do is we're going to assign the value that exists here at 20 to this variable that we call sort current output value. This is necessary in the code because I need to have a way to compare these two values. Not shown in my example is now we have to make a decision based on two factors. The first thing is we have to know whether the contents of sort current output value is 0. That would be here. If it's 0, we know that we don't need to bother doing any sort of sort comparison. In fact, all we have to do is set that value right here to whatever the current value is, and then we can escape this loop and go back to where this loop was, which would be the very next line near the bottom here. All this exit piece does is check whether the iterator is done or whether it needs to repeat. In this case, it will add 1 and go right back up to the top of the loop to start over again. If we're farther into the loop, we're actually going to do a little bit more work. So what I'm going to do on the right hand side, just to show the example, is I'll move this along to one of the farther down points so we can see what happens after we have to do a comparison. Now I have the example here on the right set up to what it would be in the code when we hit this point. So at this point here, we set the current output value to 5. And now we need to compare 5 to 1. Because we know that 5 is not equal to 0, we skip this part entirely. And then we get into the ascending check. So there is a flag called sort ascending. If this is turned on, then it's going to want to sort the values by ascending order. If it's turned off, we will do it by descending order. Since we know this is on for our example, we drop into this spot. And this is really important for how the comparison happens. If we're doing descending, we actually want to subtract the current value from whatever value is in this box. If we end up with a negative value, we know this one is larger than that. In this case, if this were descending, I did 5 minus 1, it would be a positive value, and I'd know that it is not greater than, and I'd have to move on. For ascending, I do a subtraction in the opposite way. I actually take this value and I subtract the right value. So it works a similar but opposite way. If the value becomes negative after subtracting the right value from the left, we end up knowing that this number on the left is smaller. So we want to place it in there. So our actual check condition that happens below just checks to see if the number of sort compare is less than or equal to 0. And one thing I'd like to point out, whenever you want to do any sort of comparison between two variables in Smile Game Builder, you typically need at least 2 variable entries. The first thing you need to do is set the value that you're going to test with. In this case, I use sort compare. And then I put the value in there of one of the things I want to test. The next thing you need to do is do a subtraction and subtract the two values. Typically, if they're numeric and the values are exactly the same, you'll end up with the value 0, and that's how you use that to do a comparison. Or if I'm trying to do a greater than or less than check, I want to get a negative value or a positive value, which will tell me roughly whether the number is greater than or less than the thing I'm testing. Once we move down to this section here, this is where we actually decide whether the value can be placed or whether we need to move on to the next one. Because this is 1 and because we're doing sorting of ascending, we will get a value of 0 or less when we subtract 5 from 1. And just as I notice here, I have sort descending. This actually should just be removed entirely because we've already decided that we're sorting either ascending or descending. So pay no attention to that, but I figured I would fix it while I was doing the tutorial. Now, once we know that this is a comparison that works, then we go to the process of setting the values. As you can see here, all I do is I set the value of the number displayed in sub-iterator to the current value. So for my example, if I'm right here, the number in the sub-iterator is 20, and that is this variable here. So I'm going to take the current value and set the value of this variable to 1. And because I retained this other value, which is sort current output value, I actually set the value of sort current value to sort current output value, which was 5. And now I can proceed on the code of the loop. Because we didn't have any loop exits before we got to this exit condition here, we're going to do the same check where we end up subtracting the sub-iterator from the sub-iterator end, and then we check whether it's 0 or less. Because we know in this case it's not, we will move on to adding 1 to the iterator and repeating this inner loop. And we start all over again. So now what we're going to do is we're going to take this 5 from the previous loop, and we're going to check it against variable 21. As before, we know the contents of this value is not 0, so we can move on. We also know that we're sorting ascending, so we go into this check. And so what we're going to do is set the value of sort compare to sort current value, which is 5. And then we're going to subtract sort current output value, which is 30, from 5. That will give us a negative number again. And we move on to this check and we proceed with the loop as we showed previously. We put 5 in here and we put 30 in here and we proceed with the loop as expected. I'm not going to go through all of this again because I've already walked through it once, but that's basically how this will work. Once 30 either hits 0 or 30 finds a spot that it is actually smaller than the next number, it would either swap them or exit the loop. Now, it may be surprising, but that is fundamentally the code. When you look at a sorting algorithm, a lot of it is the iterations or loops that you do to check the values against other values. So a main portion of the logic happens right here, where I do this check, or when I do this check to see whether we're doing ascending or descending. It's all about the type of checking that we're doing. The rest of this is just setting up the case where I can get the right values to test at the right time, and then making sure that I'm putting them into the right places within my array, or with Smile Game Builder, it's just within my variable set. Now this is set up as a utility sort function, which means that you could call this from many other places within code. And in fact, what I did to show this demo is I set up an example page which does just that. So let's look at that code. Here is my sort test. This is what I showed in the very beginning with my demo. So very simply, I have a message that says I'm going to generate random numbers, and then I also make sure that I set up where I want those random numbers to be generated. For my demo, I set that up at variable 900. And for this, I use local variables, so I'm not messing with any global variables. I use another loop just like I did before, except because I'm hard coding this, I didn't need to do any fancy subtractions for comparison. I just check whether the value is equal to 914, and then I can escape the loop. Otherwise, I keep adding and just generating a random number. I use 1 through 100, although I will say I noticed that I get a lot of duplicates with this, so it implies to me that the Smile Game Builder random generator isn't quite very strong. You may want to find other ways to make your numbers more random. This is very simple for the example. Once I have those numbers, I want to make sure the player can either do ascending or descending, which is what that question is about. And then I have to set up the variables. In most programming languages, when you call a method or a function, you have what they call parameters. So you call the function and you say, here are the things that you need in order to execute. Smile Game Builder doesn't have that concept. So in a way, these global variables I set up, sort start, sort size, sort output index, these are all part of the parameters necessary for sort to work. If these aren't supplied, the sort process will not work properly. So keep that in mind if you take this project and try to make the sort work. You do need to make sure every time before you call it that you set up the variables appropriately. Once that's there, you can execute the common event. I set it up with a wait to make sure the sort was fully done before I did anything else. And then I display a message at the end that just says it's done. To wrap this up, let's take a look at the same demo, but this time we'll do it sorting descending. So here we are, we're going to run our test, but first I'm going to get the debugger up and running, and I will take a look again at my variables. What's also going to be interesting to look at is I'm going to see the numbers get reset, and I will also see my sort variable output get reset as part of the test. So here we have new random numbers set up. Then we'll go down to 920. You can see it has the previously sorted values. And in this case, I'm going to say no to sort ascending. So it will use a descending sort. And here we go. 41, 88. You can see it's putting the larger numbers at top and it's moving the rest down. When it hits duplicate numbers, as you're seeing here, it's just going to place those same numbers in place wherever they're found. And this goes to what I pointed out before. I'm doing a random number between 1 and 100, and I've got 3 15s here. That seems a little suspicious. It doesn't seem like between 1 and 100 and 15 variables that you'd get 15 3 times. But as you can see, that's what it did. One other thing I should point out is that this sorting algorithm doesn't make any sort of logical decisions based upon numbers that are exactly the same. All it is doing is taking a set of numbers and putting them in sort order. If you wanted to do something even more advanced, where you can have, let's say, references to players and sorting a player order in a battle by the number of their agility, then you'd have to do a little bit more with the code. This is something that I did for Jacob Mann for the game that he's working on, and maybe at some point I will create a more advanced version of the algorithm that can handle different cases. For now, this is a simple sort, and it could be enough to get you started on creating more advanced usages for yourself. That's all for today's Mottzy Minutes. You may have noticed this was a little bit longer than the normal ones that I do. I do expect that my Mottzy Minutes will be varied in size. Originally, I thought I would be using it just for smaller tutorials, but in the end, my goal is to make these tutorials as short and sweet as possible. So I will be calling all of my tutorials from now on Mottzy Minutes. If you have any feedback, comments, or thoughts on the material I'm giving, or any ideas you'd like me to try out and do as a tutorial, please feel free to like, subscribe, and leave a comment. I'm always open to feedback, and I'd love to hear what you think about what I've been doing and whether it's working for you. Take a look in the description below for other links and helpful information about Smile Game Builder and about myself and the projects that I'm working on. Thanks again, and I'll see you next time.